Again, welcome to Statistics DSRT 734. In these lectures, we're going to discuss about hypothesis testing for proportions. In our previous lectures, we test the population mean. So our main objective is using the z-test to test population proportion. Now, in order to use the z-test to test population proportion, there's one condition that we have to meet, and that is the NP should be greater than or equal to 5, and also the NQ should be greater than or equal to 5. Again, the lowercase n stands for the sample size, lowercase p stands for the probability of success, and Q stands for the probability of failure. And this is the concept of binomial distribution. So in order to do hypothesis testing, again, we need to test that the NP and also the NQ should be greater than or equal to 5. That's using the z-test for population proportion. So the test statistics, again, will be the sample proportion, which is, again, lowercase p caret. So here we are testing the population proportion. So what we need to, again, the same step we are going to follow, hypothesis testing steps. So first we have to, again, state our HO and HA. HO is always the cream. Then HA is always going against the HO. Then the next step, we do our test statistics. Same as using the mean. So our test statistics, here the formula will be Z equal to the sample proportion. When we take a sample, we are going to find the proportion of that sample. So the P caret stands for the sample proportion. So the Z will be the sample proportion minus the population proportion divided by square root of PQ divided by N. Remember, in binomial distribution, the formula for standard deviation using proportion is P times Q over N. And again, standard deviation, the formula for standard deviation in binomial distribution using the population mean or using mean, it will be square root of NPQ. So we multiply N by P by Q, square root. But when we are doing proportion, then it will be P times Q divided by N square root. So that's the next step. We find the Z test. And we are going to again use the sample proportion minus the population proportion over the standard deviation, which will be square root of PQ over N. So when we finish that, then we have to use our table. Again, we are doing the z-test, so we have to use the standard normal table to get the value of P based on the Z value given to us. Then after that, we are going to compare it with our alpha. If we have the alpha, then that is the significance level. Then if, again, our P we get is less than or equal to the alpha, then we are going to reject HO. If it's greater than alpha, then we are going to retain HO or accept HO. So we can see that the steps are the same as our previous lectures when we are using the hypothesis testing for population mean, the same step. So the difference again is the formula for the test statistics. Since we are doing proportion, the Z value will be the sample. After we collect the sample, we will find the proportion of the sample. So the sample proportion minus the population proportion divided by square root of the standard deviation, which is the P times Q over N square root. So this is in words. We can see that the steps again is the same as doing hypothesis testing for population mean. Is the same, almost the same step as the proportion for population, also the same step. But the difference is that, first of all, we have to test if NP and NQ are greater than or equal to 5. So for example, if NP is greater than or equal to 5, but NQ is less than 5, we cannot do the test. The main reason will be we don't have enough sample, most likely. So that's the step. First, we state the claim mathematically and verbally. So we have to identify both our null hypothesis and also the alternative hypothesis. Then the second step, we specify the level of significance. So we need to know the alpha. We should identify the alpha. Most of the time, the alpha will be given to us, either 0.05, maybe a little bit less, or maybe a little bit higher. Then next, we sketch the sampling distribution. Then we determine any critical values, same step, same concept as we did in our previous lecture, using again the population mean. Then we determine the rejection area if there is. Then we also find the standardized test statistics. So our formula again is Z equal to P caret, which is the sample proportion minus population proportion, divided by the standard deviation, which is again square root of P times Q divided by N. Then from there, we make our decision. So make a decision. Now the decision will be, when we get the Z value, again, one step is not here. Of course, we know this already. When we get the Z value, then we have to go to the standard normal table to find the P value. Then we are going to compare the P with the alpha. Then we make our decision. And that based on the value of P and the alpha, we may either reject or fail to reject the null hypothesis. So we can see that the steps are the same as our previous 2 lectures. We did the hypothesis testing for population mean when the sample size is large. When the sample size is small, we use the T distribution. And now this time we are doing hypothesis testing, but this time we are testing the population proportion, not mean. So again, we will see one example soon. So the last step after we make our decision, we again interpret our decision in the context of original claim. So let's see this example. Here we have a Zogby International. They claim that 45% of people in the United States support making cigarettes illegal within the next 5 to 10 years. So there's a claim here that 45% of the people in United States support that we should make cigarettes illegal within 5 to 10 years. Now, you decided to test this claim, if this claim should be accepted or rejected. So we decided to test this claim and ask a random sample of 200 people in the United States whether they support making cigarettes illegal within the next 5 to 10 years. Now, of the 200 people, we were able to say that 49% support this law. So our alpha is 0.05. So at alpha equal to 0.05, is there enough evidence to reject the claim? So our claim here is 45% of the people in the United States support making cigarettes illegal. So we can see that this is not a mean. Previously, we have a question, for example, we say, okay, in 1970, the average or the mean weight of adult between the age of 20 to 30 in US is 145 pounds. Now, I want to check this claim if today is the same. Now, you can see that this is average weight, the mean. So I'm using hypothesis testing for the mean. Here, they give us in percentage proportion. So here we say, the question said, there's a claim of a percentage of people. We don't calculate their weight, mean, or height, or quantitative. So this would be more or less a count. 45% of population in United States support making cigarettes illegal within next 5 to 10 years. So this is the claim. Now, I want to test this claim. So I take a sample of 200 people in United States. And of these 200 people, we said 49% support this law. They gave us an alpha of 0.05. Again, we mentioned, but the reason why alpha always given is that anytime we are doing inferential statistics, there's a chance of some few positive and negative error. Let's say plus or minus 2, 1 error within our answer. So let's see this solution now. So first thing we do, of course, we want to verify if we can test. Testing of this will be based on the sample size. So if NP is greater than or equal to 5, and also NQ is greater than or equal to 5, then we can continue. And here we can see that everything will depend on the sample. The sample size is large, surely to be greater than 5. NP and NQ be greater than 5. And in this case, we have 200 times P is 0.45, so Q will be 0.55. Again, binomial distribution. Q is 1 minus P. So here we have 90 and 110. So we can continue with this testing, hypothesis testing, whether we should reject the claim or not. So we go to the next step. We need to state our HO and HA. Remember the claim is 45%. So we get P equal to 0.45. And HA always will go against P. So HA is P not equal to 0.45. Alpha is given to us, so it's 0.05. Now let's try to plot. With this alpha, we can be able to plot our distribution or rejection region. Because if it's 0.45, then we may have 0.025 to the left, 0.025 to the right, then we have the middle. So it will look something like the 0.025 and 0.025. And anytime we have alpha is equal to 0.0, we did a confidence interval. If I have Z, I'm looking for Z and alpha is 0.05, the Z value will be 1.96. But here we know again, we have the negative side and we have the positive side. And our mean Z is 0. So let's find our, now this is, right now we don't know where our P will be. Either it will be in the blue side or it will be anywhere. So we start with our test statistics now. So we find a Z. Z will give us the carat P, which is the sample proportion minus the population proportion over square root of PQ over N. So that will give me 0.49 minus 0.45 divided by square root of 0.45 times 0.55 divided by 200. So the answer here will give me 1.14. Then I will make my decision. Now when I get 1.14, I will go and check my p-value. And when I check my p-value, then we compare it to the alpha. And another option here, we can see 1.14. This is the Z value. So remember, when we have alpha, we have negative 1.96 to the left, 1.96 to the right. So 1.14 will be somewhere around the brown region area here. So if it's around here, then we are going to fail to reject HO. So here we say that the significant level is 0.05. So that's 5%. So we say at the 5% level of significance, there is not enough evidence to reject the claim that 45% of the people in US support making cigarettes illegal within the next 5 to 10 years. Because we can see our value 1.14 fall within accepted area, region. Or again, we get a Z value, 1.14, go and look for the P value. When we get the P value, then we compare the P value with the alpha. And I'm going to look at the P value right now. Hopefully, I should have done that on my slide, but So the p-value for 1.14, again, I'm using the standard normal table because this is Z. So I'll go to Z 1.1, then I'll go to 0.04. So that gave me 0.8729. 0.8729. Now 0.8729, remember, we are not doing greater or lesser, we are doing P not equal, so we're doing two area. So when I get 0.8729, that means I'm getting the score from my left to somewhere here. So what I will do is that I'm going to subtract it from 1 to give us 0.13. Then I'm going to multiply it by, it's two-way. So I'll multiply it by 2. So when we multiply by 2, I will get 87, around like 0.3 or some 0.3 or something like that. So again, the goal is that whatever value we get, if the P, in this case, the P will be greater than the alpha, greater than 0.05. So if it's greater than 0.05, then again, we cannot reject HO. We have to accept HO. And also based on the diagram here, also we can make the decision. We don't need to find the, because we can see the Z fall somewhere here at 1.14, which is accepted area, not rejection. So we have another example here. Here we have a Pew Research Center claim that more than 55% of US adults regularly watch their local television news. You decided to test this claim and asked a random sample of 425 adults in the United States whether they regularly watch their local television news. Of the 425 adults, 255 respond yes. At alpha equal to 0.05, is there enough evidence to support the claim? So again, the same step we're going to follow. Here, the claim is that more than 55% of US adults regularly watch their local television news. Then you took a sample of 425 to test this claim. Of the 425 sample you took, you were able to get some percentage, but here we say 255 respond yes. So previous example, we were giving the percentage rate, saying out of 200, 49% said yes. Now, yeah, they didn't give us the percentage, but we still can find it since the sample size is 425 and 255 out of 425 said yes. So I'm going to find the part. So I'll divide 255 by 425 to get the percentage. So let's go through the steps now. First thing we want to do is MP. Here the N again is 425, very big. It's a very large sample. So we're sure we are going to pass the 5. So MP should be greater or equal to 5. NQ should be greater or equal to 5. So here we get 235 and again 191. The sample size is very big. Then next, we state our HO and HA. When we look at the question, we have 55%, that's the claim. So which means our HO will be P is less than or equal to 0.55 and HA is greater than 0.55. Again, based on the question here, they say the Pew Research Center claimed that more than 55% of US adults regularly watch. So more than their local, so the HA become greater than 0.55. In that case, HOVP is less than or equal to 0.55. Now there's a different, always students, we used to have a problem, a little bit confusion here. Let's look at the previous question. You see that the previous question, they say equal. International claims that 45% of the people in the United States support. So this is exactly 45% equal. So this will be our HO. But if the question should have said, Zogby International claimed that more than or less than 45% of people, if we say more than 45% of the people, then this become our more than become our HO. Then, I mean HA. Then HO will be less than or equal. And the other way is to opposite. So that's what we have here. After we test, more than 55% is HA. So less than or equal will be 0.55. We also have our significant level, the same thing. If I know my significant level, then I should be able to construct my reject. But this time, look what we did. Before it was equal. So we get both sides equal. Equal is two-way. From the beginning, we said if we are testing HA not equal, then it's two-way because it can be greater or less. But here, since we say greater than 0.55, more than, so we have only the greater part. So the whole alpha will be on the greater part. Now, when you look at the Z, we get 1.645. Previously, we used 0.025 because you have 0.025 here, 0.025. So if you're looking for Z and the alpha is 0.025, you get 1.96 because it will be Z1 minus alpha over 2. So we have our original. Now let's do our test statistics. We use the formula again, the sample proportion minus population proportion over the standard deviation. So we do our calculation here, we should get 2.07. Remember where 2.07 will be falling inside the blue, not the brown area. You see our previous example, the first example, the Z value fall inside the brown area, so we fail to reject. This time it fall in the blue, so we are going to do what? Reject HO. So our decision will be at 5% level of significance. There is enough evidence to support the claim that more than 55% of US adults regularly watch their local television news. So again, when we construct, the construction of this distribution will depend on the value of the alpha significance level. Since this is one way, the 0.0 and is more than the 0.05 is go to the right. Now, if it should be less than, then 0.05 will be on the left. So which means our rejecting region will be the left side. So here our rejecting region of HO will be on the right side because it's more than 0.55. So again, we are going to end this lecture here. So in these lectures, again, we learn how to do the hypothesis testing using population proportion. So we saw the format. Again, the steps are the same. We went through hypothesis testing using the population mean. With the population proportion, the first thing we need to do is to test NP and NQ are greater than or equal to 5. Then if this condition is true, then we can continue testing. So we're going to state our HO and HA. Then if possible, we get our alpha value, then we sketch our distribution region. Then we can identify our rejection region based on the alpha value given to us. Then we look for the value of the Z-test. Now, if we look at the value and the value fall in the rejection area in our graph, then we're going to reject HO. If it fall around the retain area, the retain area areas we saw before will be in this slice, to be the brown area here. The alpha value sections are where we are going to reject our HO. Then, so after we're able to find a Z, then we make our decision based on the value of Z, either to reject or retain HO. So those are the steps. As we can see, The hypothesis testing steps are the same concept. The difference is we are using different values here or formula. The test statistics now consists of proportions because we are testing proportion. So again, wish everybody the best and thank you for your time.